stage for why containers and container orchestration are so important. By this point, you may be wondering, with software dedicated to such large tasks at such a large scale, how does one get started and interact with it in a manageable, easy way? Luckily, there's a very good answer to this question that's easy to approach and easy to get started with. As we discussed in the last lecture, this is what Minikube is all about: a distribution and package of the actual Kubernetes code that runs in an entire Kubernetes cluster on your laptop. Remember, Minikube isn't something you'd want to use in production or even staging for an application. What makes it great for training, development, and learning makes it quite useless for production. It's a great way to get into Kubernetes quickly, easily, and without the headache and hassle of a number of other things that are required for production use. Let's get started by installing Kubernetes. But first, make sure you have a Linux machine with the latest version of VirtualBox installed, or a Mac with the latest version of VirtualBox or VMware Fusion. As we set up Minikube, take notice of how we interact with it, the patterns of the commands and the like, how they're structured, for example. These should be pretty familiar, if not identical, to how you work with full Kubernetes clusters. Because remember, Minikube is the actual Kubernetes code, and we will use the actual Kubernetes command line tools to interact with it just as if it was a full production remote cluster. As we've mentioned before, Minikube requires Linux or Mac machines capable of virtualization with a hypervisor installed. On Mac OS, this can be any number of hypervisors, such as XHYVE, VirtualBox, or VMware Fusion. On Linux, this can be VirtualBox or KVM. VirtualBox is by far the most popular and is available at http://www.virtualbox.org. We'll start with installing a package called kubectl. This is the command line control tools for Kubernetes clusters. Whether it's a Minikube or a full-blown cloud-hosted cluster, you'll use this command line package to interact with your cluster of choice, including the Minikube cluster we're setting up today. Then we'll actually install Minikube and go through a few basic commands on how to work with it. As we dive into our first hands-on example, it's time to discuss a bit of detail as to how Kubernetes organizes concepts and a bit of terminology so this will all make sense. First, a central concept in Kubernetes is the deployment. It is a large, general, high-level construct that groups together the various parts of an application. You can, for now, consider a deployment to be akin to an application that you'd like to deploy, thus the name deployment. Second, deployments have pods. A pod is a group of one or more containers for an application. A pod is an instance of a container image, and there can be many of them in a deployment as needed. Third, services are endpoints that expose network ports to the outside world and are mapped to a port on a given pod for a deployment. This is how end users or intermediate services might access the services exposed by your pod or your container image you're looking to deploy. There are various types of services that we'll get into later in the lecture series. For now, just consider services as network ports that expose an application. First, let's install kubectl, the command line utility used to interact with Kubernetes clusters. You'll use this tool for both our local Minikube instance and any remote clusters you may manage or interact with. These installation instructions are built against Kubernetes 1.8 and guide you through manually installing and downloading the kubectl executable and installing it into your path. If you're familiar and comfortable with your specific operating system's package manager options, it may be beneficial to use such a route to install and maintain the latest version. For example, on macOS, the Homebrew Package Manager provides simple and straightforward installation and maintenance of the kubectl package. And several unofficial Debian sources exist for use with the apt package system on various Linux distributions. If you're comfortable and aware of how to use your operating system's package manager, we recommend using it to install and maintain the kubectl command set. You can skip these installation instructions if you'd like to use your operating system's package manager. If so, rejoin us on the next slide for testing your installation and moving on to Minikube. We'll begin by using Google to find the appropriate documentation. let's Google install and set up kubectl. The first hit's exactly what we're looking for, the Kubernetes documentation on setting up kubectl. Let's go here and scroll down to the area that includes the URL to download for our platform. We'll choose Linux. Let's copy the URL and the command all at once so we don't have to retype it. With this copied to our clipboard, we'll now begin installation. And remember, we copied the URL, but you're also free to copy subsequent commands out of the Kubernetes documentation if you'd like to avoid retyping them. We'll start by downloading the appropriate package for our operating system, in this case, Linux. Once the download's completed, we'll make it executable. This step is not required on Windows. Now, we'll finally copy it into our path so it's executable no matter what directory we might be in. Now that you have kubectl installed, let's check to make sure it works properly. At the command line, type kubectl version. It should output something similar to what you see on the screen here. Your version numbers may be different, and your git commit numbers are certainly going to be different. But as long as the command was found and it returns something similar to what you see here, you can be relatively confident that your install went well. Let's run this command on our Linux instance to see what its output looks like. Don't be alarmed at the error. This is just because we haven't set up a Kubernetes instance. Now that we have kubectl properly installed and working, let's move on to installing Minikube. Again, these installation instructions are built against Kubernetes 1.8 and guide you through manually installing and downloading Minikube and installing it into your path. If you're familiar and comfortable with your specific operating system's package manager, again, we recommend that you use that option to install Minikube. On macOS, the Homebrew package manager sometimes provides the Minikube formulas, and on unofficial Debian sources exist for use with the apt package management system again. Once again, let's consult Google for the appropriate page. We'll Google installing Minikube release. Again, the first result in this case is what we're looking for, the releases page on GitHub from the Minikube project. Let's go there. Let's scroll down on the latest release to the installation instructions and URLs. Again, let's copy the appropriate one for our platform to avoid having to retype it. Remember, you can continue to do this for subsequent instructions if you'd like to avoid retyping them. With this in our clipboard, let's move on to the actual install steps. We'll use the appropriate command to install Minikube for our operating system. Now that you have Minikube set up in your system, let's go through some basic Minikube commands. Before we get started, remember, you can copy and paste these commands from the text lecture at any point. Each one of these commands is available for you to copy and paste in this lecture and in subsequent examples. To begin, let's actually start our Minikube cluster by typing minikube start. It will take some time to download the various images and get the cluster started on your machine. If your machine's as slow as mine, you may want to go get a beer. You'll notice the kubectl is configured to use the cluster. Minikube does this for us automatically. Let's use kubectl to actually deploy the Hello Minikube sample application. We use the kubectl run command to deploy a sample image to our Kubernetes cluster. This command is worth noting. We'll use it extensively throughout this example and in future lectures. This command provides a simple and quick way to run a given Docker image on your Kubernetes cluster. While you may want to package a Docker image with more sophistication for full orchestration capabilities, the kubectl run command provides you the ability to quickly and in a straightforward way run a given image on a Kubernetes cluster when you need to. It's a useful command that you should note. We'll go further in depth about the usage of the kubectl run command in further lectures. Now that it's deployed, let's expose the Minikube sample application using the service command. This command will take the application, which is running locally in our Kubernetes cluster, and allow external IP addresses to access it. You may have noticed the use of the word deployment. In Kubernetes, a deployment is any set of resources that deploys a container, an application, a set of containers, or pods. We'll go further in depth as to what deployments are and how to work with them later in the course. The kubectl expose command is another command that you'll likely end up using quite frequently throughout your time with Kubernetes. Take some time to understand exactly what it does. In this case, we're exposing the deployment hello minikube with a service of type node port. There are a variety of types of services that are available. Specifying a node port allows us to have an external IP address connected to the port on the container that we just deployed using kubectl run. Other types include cluster IP, which is a private IP not available to the external world, and load balancer. Load balancer requires external functionality from either the hypervisor, the cloud provider, or the host upon which Kubernetes is running. We'll get into the specific types and other varieties later on in the course. You'll see the service was created. We can use the git pod command of the kubectl command line tool to see the status. It's running, has no restarts, and has been running for 46 seconds. We can now access the cluster and actually access the data on the service using the curl command. You'll notice in this case, we used the Minikube service to be able to get the URL of our pod. The output, as we expected, gives us an HTTP response. And finally, when you're done with the deployment, or no longer need a deployment, or would like to replace it, you can use the kubectl delete deployment command to specify a deployment for deletion. You can also